All right. So the very first example that we're going to try is log x equals 2. And we're going to solve this one for x. Okay? How many of you can just look at it and see that you know what x has to be? Does anyone know what x has to be? Pardon me? It has to be bigger than 0. Yeah, it has to be positive. That's true.
It has to be over 1.
It has to be over 1. It doesn't have to be over 1, no. It has to be greater than 0 and not equal to 1. Okay, so we can have numbers between 0 and 1.
But will it like that x minus 1? Can we not have the thing equal to
We're looking at this one. Sorry, thanks, Owen. You're ahead of the game, though. Otherwise, yes. Okay, so we're looking at log x equals 2. Does anyone know, just by looking at it, what x has to be? Log of what is 2? Nobody knows? Curtis? 100, okay? Log of 100 is 2, because the base here is 10. So base 10, log base 10 of 100 is 2, okay? So that's just called solving by inspection. When it's a pretty simple equation that you're looking at, often, or not often, but when it's a simple equation, lots of times you'll be able to just look at it and say, okay, yeah, x has to be 100. So a simple one like this, okay? But let's say that you can't do it by inspection. The easiest way to do it is to change it into exponential form. So if you take the base here, which is 10, and then what's the exponent in this equation? Nicole, what's the exponent in this equation? The log is equal to the exponent. So the exponent is 2, and that's equal to the argument. So x equals 100. Okay? The other way to do it, which doesn't make much sense in this particular question, and I'll show you why in a minute, is to change both sides to logarithms. Because we'll have log x, and if we want to change 2 into a log, as Curtis said before, it's log 100, because log 100 equals 2. But if you already know that, then clearly you know that x must be 100. Okay? But when you have logs that are equal to each other, that have the same base, then the arguments must be equal. And so our x equals 100. Okay? Questions about that? I don't know why it's asking me that all the time. Okay, so then our next question is that one. Okay? And Owen, you're absolutely right that x will have to be greater than 1 in this case, so we don't have any negative logs. Okay? However, we don't have to think about that ahead of time necessarily, because I'll show you what we can do to make sure that we always have a positive argument. Okay, so we have log base 3 of x plus log base 3 of x minus 1 equals log base 3 of 6. What are we going to do? Yep.
Because they're all the same base, you can multiply the x times x minus 1.
Yeah, so we're going to combine these to make a single log on the one side using our product law. Okay, so we're going to have log base 3, and we're going to use the product law, which tells me to multiply these because we're adding single logs, and so we can combine them to make one log by multiplying the product. Okay? So now when we have a setup where we have a log equal to a log, and the bases are the same, then I can already tell this is not going to be a very good video to post. I don't know why that keeps coming up. Then, since the logs are the same, the bases are the same, the arguments must also be the same. So we have x onto x minus 1 equals 6. Okay? And I need to solve that for x. So what am I going to do to solve that for x? Yep. Yeah, and I'm also going to get rid of the bracket, so I'll have x squared minus x minus 6 equals 0. And then what? factor it. So x minus 3, x plus 2. So therefore x equals 3 or equals negative 2. Okay? So remember what Owen was saying, that we need to have x greater than 1. And he's absolutely right. We need to make sure, no matter how many solutions we end up with, we can have 1, 2, 3, whatever. We can have a lot of solutions down here. No matter how many we get, we're going to have to check them. And so we check them. You can check them and plug them in and do a full check to see if you're actually getting the right answer. How about that? We can check them to see if we're getting the right answer, but at the very minimum, you have to check them to make sure you don't get a negative argument. Okay? So you have to check each solution to make sure the argument stays positive. So if I put x equals 3 in here, I get log base 3 of 3 plus log base 3 of 3 minus 1, which is 2. And that's fine, because both of those are, all of those arguments are positive. That one we already had. These two, when I put the 3 in, I get positive arguments. But when I put the negative 2 in, I get right there and right here negative arguments. And so those aren't allowed. Okay? So negative 2 is extraneous. And positive 3 is the actual solution. Okay? Now let me just point out that I don't have to make all the arguments negative. If it even just makes one argument negative, it's no good. Okay? So we've got to check all the solutions, but we don't have to check it in every x. We just need to find one x that is negative, and then that's it. It rules it out. Okay? It could be that both of these make all the arguments negative, or make one argument negative. So we might have no solution, or they both might work just fine. In that case, they'd be two solutions. So we do have to check them. And it isn't the negative, here it is the negative solution that makes the argument negative. But that isn't necessarily always going to be the case. It could be the positive solution that makes the argument negative. The question is the argument positive or is it negative? Positive arguments are good, negative arguments are bad. Okay? Questions about that? All right, so let's try another example here. We have log of 3x plus 2 plus log of x minus 1 equals 2. What will we do here? Yeah, so we're going to use our product law again. And make a single log on the left. Now we can change that 2 into a single log. Or, at this stage, because we have a single log equal to a constant, we can change it into exponential form. So if we change it into exponential form, what is the base here? Jasmine, what's the base? Okay? And then what's the exponent? Curtis Backen, what's the exponent? 2. And then we have 3x plus 2 times x minus 1. Okay? Which is exactly the same thing we would get if we changed the other side to be a log, because log base 10 of 2 is 100. And so we'd have log of this equals log of 100, and so this would be equal to 100. Okay? And that's what we have. So I'm going to simplify the left. I'm going to get rid of brackets. So I have 3x squared minus x minus 102 equals 0. And to solve that, I'm going to try to factor. To factor, I need numbers that multiply to 306, sorry, negative 306, and add to negative 1. Any ideas what those two numbers are? Okay, I know the numbers have to be close together, right? Because they have a difference of negative 1. I know one has to be positive and one has to be negative, and they're going to add to negative 1, so they're close, right? So take the square root of 306 with your calculator. What is it? 17 point something, right? So that's telling me that 17 and a bit times 17 and a bit gives me 306. So I'm going to try numbers that are close to 17. So 17, 18, 16, 19. Which one of those divides into here? What's 306 divided by 17, for example? 18. So 17 and 18 are the ones, okay? It's not magical. It's just using some logic that I know I need numbers that are close together. So the square root gives exactly the same number, so close to the square root is going to be what I'm looking for. Now I need one of them to be negative. Which one? 18. Yes? Yeah. Are we doing it differently? Well, the part that we're doing differently is that we are changing this to exponential form rather than we don't have a log on both sides. You can do it either way. In this case, but in the other case, no. In the other case, you had a log on both sides, okay? And so you stay with the log on both sides, but then you just make the arguments equal, okay? If I wanted to do that in this case, I could do that. I could have changed the 2 to be log what? Log what is 2? If it's base 10, it's 100. And so then I would have the arguments equal. I'd have 100 equals that. So I get the exact same thing.
Yeah.
Okay? Okay, so I'm going to factor. I know I need to multiply to 3x squared, so that's 3x and x. I know I need to make 17 and negative 18. So I'm going to multiply this by minus 6 to give me the minus 18. And I'm going to multiply this by 17 to give me the positive 17. So therefore, the zeros are negative 17 over 3 or positive 6. Okay? I'm going to check them to make sure that the arguments are positive. Notice that if I put negative 17 over 3 here, I think, oh, I don't want to do that. That's a fraction. Let me try this one. Negative 17 over 3. If I have a negative and I subtract 1 from it, I get a negative. So negative 17 over 3 is no good. It's extraneous. But positive 6 gives me a positive number there, and 6 minus 1 is 5. That's a positive number there. So the solution is 6. Okay? Questions about that? Okay, so we are going to try some of these at the board in a few minutes, but before we do, I want to remind you of what we've been doing. So if those of you that like a little bit more formal structure, okay, this is what we're doing. We're using the laws of logs, okay, and our goal when we do that is either to get a single log on both sides of the equation or a single log on one side and a constant on the other. Those are your two possibilities, okay? So that's how you're trying to rearrange your equation to look like. If you have single logs on both sides, I'm calling that type A. And if you have one log on one side and a constant on the other, I'm calling that type B. And if you have type A, if you've got log equals log, you set your arguments equal. If you have type B, log equals constant, then you change to exponential form. Okay? And you're going to get the same equation.